This is not a lot of original thought. These are ideas that I've gleaned from other people or from talking to people, all these things also. So let's start with the basics. And the basics, we'll start with some definitions right here. There's a change set, a change list, and a pull request. Change set and change list are often used interchangeably, but they're not the same thing. A change set is code that I have changed. Maybe I'm fixing a bug, maybe I'm adding a new feature, maybe I'm adding a new software or changing existing software, whatever. It's all the lines of code that I've either added, deleted, or modified within the code base as a given set. Typically, it'll be for just one feature or one bug fix, something like that. The change list is the documentation of that, the list of things that I've changed, the files that I've changed, and the reason that I've changed them. A pull request is a request to merge that change set into the main branch of my source control repository. So a good software design system, a good software development lifecycle system will have something set up where you cannot check code directly into the main branch. For your old timers, that might be called the master branch, but we're typically calling it the main branch now. The branch that is ultimately going to go into production. We won't be able to check anything into that branch until it's been vetted by a third party. And that request to check it in is called a pull request. And there's in this process of code reviews, there's two primary people involved: the code author and the code reviewer. Code author, of course, the person that's making the change, adding or deleting code, and the code reviewer looks at that change, and they're the gatekeeper. They're going to vet that this code is good enough to get merged with the main branch. And the process looks kind of like this. The author writes their changes, submits a pull request, all the code along with a list of what those changes are. The code reviewer then looks at those changes, runs them, tests them, does whatever. Basically, it's a vetting process. Decides thumbs up, yes, this is good enough to get merged with the main branch, or no, there's problems with it. And if there are problems with it, the code reviewer will then document those problems and send them back to the code author to address those problems. The code author may make changes based on this, or they may explain why this is it's not a bug, it's a feature. This is actually designed that way. There may be some conversations that go back and forth here, but ultimately the code author is going to address each one of the issues the code reviewer came up with, send it back, and this sort of ping pong will go back and forth until the reviewer gives the thumbs up and said, you know what, this is good enough. This can be merged in with the main branch. And that's the end of the code review process until the next pull request. Why do we do this? There's a lot of reasons here: validating code, sharing knowledge, increasing code ownership. I'm going to talk about each one of these individually here. First thing is validating code. Now, the most obvious thing is we're going to validate the external code. In other words, does the code do what it's supposed to do? If it's fixing a bug, is the bug fixed? If it's adding a new feature, does it perform the functionality described in the feature request? That's really what most people think about when they think about a code review, is making sure that the code does what it's expected to do. But there's more than just the external part of it. There's the internal part of it. We want to look at the code and want to determine if the team has guidelines to follow those guidelines. Are there potential problems? Is it inefficient? Is it slow, for example? Are there easier ways to do this? Is it duplicating code? Is it hard to read? Are there other ways that it can be improved? Because even if it meets all of the functional requirements, there may be reasons why we would want to reject this code and send it back to improve it. Another good reason is we want to share knowledge. Code reviews are a really good opportunity to share knowledge among members of a team. I've been on teams where everybody was assigned a part of the application, and nobody except for that person knew anything about that part of the application. They didn't know the code base. They didn't know the business rules. They might not even know the technology that's involved in that. And you probably know this as your .NET developers, that every software developer in the world has a bus and a lottery ticket assigned to them. And so I've been in lots of meetings where I was hypothetically hit by a hypothetical bus, or hypothetically won the hypothetical lottery. What are we going to do if David gets run over by this bus? Nobody else understands his code. If he gets run over, or if he wins the lottery and quits, then who's going to maintain his code? Nobody understands. It's a bunch of spaghetti logic written in some foreign language. That knowledge is trapped inside of David's mind. Well, if someone else is reviewing David's code, then we're spreading that knowledge around. We're spreading that knowledge about what does the code do, what are the business rules it's trying to solve, what is the actual code itself doing, what's the technology using, what libraries is he using, things like that. So there's some value in that, just in case I either win the lottery or get hit by a bus. I think I prefer the former over the latter, but regardless, we're mitigating the risk of me leaving the team and leaving folks, the organization, unprotected. Another good reason is it helps us to make engineering decisions. Ideally, you want to make these engineering decisions like, test how are we going to test things. So what kind of data access layers are we going to use? What are our naming conventions, our other coding standards? But as you review code, you may realize that some of those things are not clearly defined. Maybe there's some inconsistencies in the way that people are doing these things, the design patterns they're using, for example. And reviewing code will bring those to light, and it may cause us to say, hey, let's step back and do a better job of defining this, because we want some consistency in this. We can also address weaknesses. Of course, we're going to address weaknesses in the code. If we find problems in the code, we're going to have the code author fix them before they get merged in the main branch. But by finding issues in the code, it may reveal weaknesses in the developer. Maybe the developer doesn't understand a certain way of doing things. Maybe they're doing things inefficiently because they don't recognize certain design patterns, or they're not aware that libraries exist to do this stuff. It's a chance to educate people, because now you're spreading knowledge among different people. The code reviewers are giving feedback to the developers that could just make them better developers. I used the word consistency before. Consistency is a good thing when you're in a group organization, because it makes code a lot more maintainable. And code reviews are a good way to ensure that there is consistency among the different code parts of your application. And therefore, if this bus or lottery ticket comes along, somebody else has to maintain it, they have a better chance of understanding it, because we're using the same patterns, we're using the same libraries, we're using the same naming conventions, all those things. Ideally, you should be setting those things up front, but defining those things up front, regardless of how it's communicated, consistency is a very good thing. What else? Let's see. Compliance, I throw this out because I've been in organizations where code reviewers were actually mandated. I did work for a federal home loan bank that was kind of a quasi-government agency, and they wanted documentation on what kind of code reviews we were doing before we checked our code in. Sometimes it's just required either by law or by organizations. So this is a good way of checking the box. There are other reasons for doing it, but sometimes it's actually required. There are also like some CMMI maturity levels if you want to achieve ISO certifications. Those require some sort of quality checks, like a code review, to pass those certifications. And then there are long-term benefits to this. Catching problems sooner is a big one. I'll talk about that in a second. That I revealed that in the case of Jack and Joe at the beginning, but also less time for rework, fewer service calls and support. If you can catch things internally and not get them out to the public, then we're not going to be dealing with angry customers, and fewer issues in integration testing and user acceptance testing. Basically, the sooner you can catch things, the sooner you catch a problem, the better it is. This is known as the shift left principle. And what the shift rest principle says, that the sooner we resolve a problem, the less expensive it is to correct that problem. In fact, it goes up exponentially as time goes on. So there aren't any numbers on here, but still this graph holds true, that if I am writing my code and I notice, oh, I've got an error on the line above, I can just backspace fix the error. It costs me pennies to fix that. If I check something, if I create a pull request and the reviewer catches it, it might cost a couple of dollars to check it, because they're going to return that to me. I'm going to fix it and send it back to them. It's a very small thing. But if it goes into user acceptance testing and they catch it, then we've got a longer problem. We've got more of a feedback loop, and we've got to recreate the environment, which may be a week old, and we need to get back into their head and understand where we were at that point. If it goes out into production, there could be problems, because now we've got bad publicity from a bug being found, and again, more time has passed, and we have to recreate that environment as when the bug occurred, and we have to get our head back into understanding where we were at that time. And it's even possible that if it goes far enough, it might actually damage data. Maybe a bug in there that actually corrupts data. Now we've got to undo some data changes. So as time goes on, the further the further from the writing, between the time between the writing of the code and the discovery of the bug, gets more and more expensive to fix that bug. And that's the shift left principle. Left in terms of time is a lot cheaper. All right, so I think hopefully by now, if you weren't convinced already that code reviews are a good thing, now you are. You realize there are lots and lots of benefits to doing code reviews. It can increase the quality of your code. And yet, not everyone is doing code reviews. So why not? Well, there's reasons why not, because there are some challenges here. There's the challenges for both the author and the reviewer, and I've listed them here. The big one is time. Code reviews take time, and they take energy, and not everybody has an unlimited amount of either one of those. Nobody has the unlimited amount of either one of those. And the time you spend reviewing code is time that is not spent doing something else, like writing new features. I've never been in an organization that had a full-time code reviewer. Typically, that reviewer has some other responsibility. And while they're reviewing code, they're not doing that other responsibility. Maybe they're actually also writing code themselves. Also, reviews can often block other changes. So while you're waiting to fix this one problem in the code, or at least verify that there isn't a problem with that code, then it may prevent you from building new solutions on top of that code. You want to make sure that it's right. This fourth one, communication, miscommunication, this is a huge one. We as humans, we communicate either through written words and through verbally. Typically, code reviews are done through written words. There are systems where you can write in your change list, and as an author and the reviewer will write comments when they send it back. And there's always, what I am trying to say may not be what you actually hear or what you actually read. This happens all the time. It's even more pronounced in written communication because we don't have the nuances of a verbal communication. We don't have the visual cues of face-to-face communication. So there's a potential to miscommunicate and misunderstand what we're trying to do. And this whole code review process is very much about communication. There's also this idea of individual accomplishments versus collaboration. And this is, I think, a function of our American education system. In the U.S., we tend to value individual accomplishments over collaboration. That tends to be what we're being graded on. Sometimes even in the corporate world. I had a manager once who, when I told him that we had created a new feature, we had solved this problem, he didn't want to know the problem was solved. He wanted to know, what did I do? What was my contribution to it? Because the fact the problem was solved was less important to him than whether or not I had contributed to it, which is, we can debate whether that was a good manager or not. But this is sort of the mentality we grow up with, is that we take pride in our individual accomplishments more than our collaboration. And that's rewarded, I think, as we're going through school. And so, but here, writing code is often a collaborative process. And code reviews are a collaborative process as well. So that's a challenge. And part of that is you may have different opinions. I, as the author of the code, may think it should be done one way. The reviewer may think it's done differently. And maybe we're both correct. Maybe one of us is more correct than the other. It's possible, but there's very little dogma in software development. There's often multiple correct ways of doing things, and we have to accept that. We have to understand that. And if we don't understand that, sometimes we can get into what's called a stalemate, in which case we're both convinced that we're the most correct, and therefore the other person is wrong, and we don't want to budge. And we'll talk about ways to resolve stalemates later on this talk. All right. So those are challenges that are both the reviewer and the author have. These are specific just to the reviewer. A lot of us have issues trying to point out errors in other people's work. Who am I to judge his code? I mean, he wrote the code, he studied it, he knows the business rules, he met with a business user, he's the expert of this whole subsystem, and yet here I am judging him. It's kind of an imposter syndrome thing you have to get over, to say, maybe, yeah, he knows more than I do, but he doesn't know everything. Maybe a fresh set of eyes are a good thing, but that's a challenge. I may know less about the language he's writing in. I may know less about the business processes, the business rules he's trying to enforce, but I still have access to the documentation, trying to understand that. And then, of course, I mentioned this before, that reviews do interrupt your workflow. So not only do they take time and they take mental energy, but they're context switching. So if I have a day job where primarily my job is to write software or be a project manager or whatever it is, then when a code review comes in, when I start working on it, I've got to switch context and get into that code, and then switch back when I'm done, switch back into this. And this is also a challenge. It interrupts my workflow, and I have to think about something brand new while I'm doing the review. Here's a few challenges that are specific to the code author. One of them has to do with communication, criticism. It sounds like when we write code, I know I take a lot of pride in the code that I write. Sometimes I take the ownership in it, and I want it to be perfect. And when someone comes back and criticizes my code, tells me the problem with my code, sometimes it feels like they're criticizing me, or they're criticizing my baby, because I've actually internalized the code. And that's a problem with something that we need to separate ourselves. Your code is not you. Just because there's a problem with code doesn't mean that you're a bad person. But it's easy to take it that way, especially if you have somebody who's very abrupt and isn't really good at delivering communication. They may make it sound like it's your fault. And the other one is a sometimes problem. Sometimes management will actually grade you on the number of bugs they found in your software. And I have experienced that before. These are not good managers. It's a really bad idea, because one, it discourages people from finding bugs, so they don't want to get other folks in trouble. And also it makes those of us who very defensive. I don't want, we're going to, rather than trying to fix the bug immediately, our immediate reaction is to push back and say, no, this is not a bug, this is a feature, this is the way it's supposed to be, as opposed to keeping an open mind and doing that. So these are challenges that we need to get past. All right, so there's lots of challenges. The reason why not everyone is doing code reviews, that's the bad news. The good news is we can address those challenges. And I'm going to talk about that for most of this rest of this presentation. These are for the code reviewer. So the person that's reviewing the code, not the code author. What can you do? One of the best things you can do is to start right away. Start as soon as possible. Now, it's not always possible to start right away. You've got your other job, and you're working on to finish the task and get into it. But be aware that the longer that you delay, then the harder it's going to be for them to fix any issues that you send back to them. Because the sooner you begin, the sooner you can provide feedback to the code author, and everything will go more smoothly if the original code change are still fresh in the mind of the code author when they receive the feedback. If they've moved on to some other task, it's 2 weeks later and they've actually changed the code a lot, they're doing something completely different. Now you send them an issue of code they wrote weeks ago. Now they've got to get it back in their head. What was I doing? What was I thinking at the time of this? It'll make it a lot harder. Decreasing that feedback loop time has real advantages. And it also reduces the risk that maybe they've made changes to the code base that they have to roll back in order to fix this code. And maybe those changes are actually dependent upon this code. So fixing the code might actually slow down the changes they're doing right now. So this is a big one here. The quicker you can start your review process, the quicker you can get the feedback back to the author, the better it is for everyone. Next tip, use the computer for things that the computer is good at. So as a reviewer, the first thing you should do is pull the code down from the repository, compile it, run any automated tests that are associated with it, and verify that they all pass. And use tools that can test, like if you have any linting tools to test for things like white spaces or naming conventions, there are tools that do that, or styling tools that are available in different languages. And run anything automated. Let the computer do the things the computer is good at. And if any of those automated things fail, stop right there and just send it back. You know what? This code doesn't compile. No, there's a unit test here that's failing. No, you were supposed to have tabs and use spaces, or use spaces, but you use the wrong number of spaces. Stop right there. There's no point in going on. It's a simple fix. Send it right back. Let them fix these things right away before you proceed. And then speaking of things, tabs and spaces and naming conventions, every team should have a style guide that describes what their naming conventions should be, what their class name should be like, how long classes should be, how should they be structured, what's the folder structure of these things, what's tabs versus spaces, whether multiple classes per file. All these things should go into a style guide and published somewhere for anyone to use. You can create your own, but it's a better idea just to start with one already. I've got a link to here. Google has a really good one right here. If you go to this link, then You'll see that they have style guides in a lot of different languages. You can just take out the part that's relevant to you and save that, and then decide whether you agree with it or not. You may want to add to it. You may want to change some things. You don't have to agree with everything, but it's a good starting point. And then be aware that it can evolve over time. After a while, you may say, you know what, we've been doing it this way, but boy, that's just not right for us. It's a living document. Work high level to low level. This is a good tool. What I mean by that is high level of things like with the class structure and interface direction declarations, things like that. Low level is the actual code itself, the individual lines of code. And what you'll discover is that if the change set includes a lot of high level changes, those may, by addressing those and looking at those first, those may lead you into changes at the lines of code. Whereas the opposite is not true. If you start at the lowest level and start looking at lines of code, that will never lead you to changing the directory structure or just validating the directory structure. You want to start with the broad and then narrow focus set. Include code examples. So if there's an issue with the code, if there's a way that it should be rewritten, suggest a better way. And that could be pseudocode. It could be links to blog posts that show how to do the code. Help the developer out. They might not know the technique you're talking about, the algorithms, the libraries you're referring to. Help them out with some samples. I would caution you on, don't try to write the code for them. That's not your job. You don't want to spend time on that. But you don't want to have to guess what they should be doing. So if they should be using the decorator pattern, for example, include a link to the decorator pattern, and preferably with samples in the language in which they are writing. And then don't make it personal. I brought this up as one of the big challenges that we as developers, we may take offense at someone criticizing us. As the code reviewer, you want to be sensitive to that. And so avoid the word you entirely. Instead of saying you wrote bad code, you can say the code doesn't do this, or the code should do this, things like that. Talk about the code. Talk about the changes that need to be made. Don't talk about the person. Don't challenge them to internalize that. Just think about what you're saying. Phrase things as requests rather than commands. Phrases like consider splitting this into two classes. Consider splitting this into two methods. Consider renaming this, as opposed to rename this. And then also cite principles. If you just say this method is too long, or this class is too long and does too many things, that sounds like an opinion. But if you say this class violates the single responsibility principle because it both adds customers and retrieves customers, maybe that would be a good, then you're pointing to a principle. And if everybody agrees that the single responsibility principle is a good thing, then it's tougher to argue that. Whereas if it's just your opinion, you may fall into that ping pong back and forth stalemate, arguing my opinion versus your opinion. Here's one I just recently started using. This is adding prefix to your comments. So when you're writing your code reviews, often you'll find a line of code or a section of code and you put a comment in there, but adding these prefixes, and you don't have to use these, you can just come up with your own, but these came from this article that I've linked down here, Conventional Comments, and issue, suggestion, question, nit, chore, thought, and praise. And that basically gives a clue as to what the comment is about. So an issue is something that has to change. It's, you better, I'm not going to pass it until you've actually changed this. I'm going to send it back to you, so fix this. A suggestion, they don't have to change it, but it's worth thinking about. Consider splitting this into two methods, for example. I'll probably still pass it if they don't do that, but that's my opinion. A question may or may not be a problem. I don't understand why you did this. Just answer it. And if it's an acceptable answer, yes, I'll pass it. If the answer isn't a good one, maybe they didn't think about it, and then they may change it. But if it's not a good one, then I won't pass it. I just want to answer this question before I pass it. So in this case, well, there's a lot of different ways of doing collections inside of .NET. Why did you choose this one over that one? A nit has to get done, but I'm just acknowledging that's a tiny thing. Maybe it's a spelling error or a name of a method or something like that. It's a quick fix. Yeah, it's a bother, but just do it. A chore is sort of like a nit, but it's more work. Removing unused import statements, that's a common thing. You got lots of import statements, and then you stop using them, and it clutters up the code. And yeah, it's a chore to do that because it might be in a lot of different classes, but just acknowledge that, yeah, it's kind of busy work, but it should be done. A thought is just an idea to consider in the future. No reason, I'm not going to hold up a pull request for that. A good example is you've written all this code. There's a library that will do that. Take a look at this library. It might help you out. You don't have to write all this custom code to do it. Use this open source library, this commercial product that we already have. And then the last one, oh, this was eye-opening when I first read this. Praise. Adding some praise. Just put in there, wow, this is really good. I like this idea. What a clever idea. I've always thought of code reviews as a way of pointing out problems in the code, but it's also an opportunity to point out the good things in the code. You made a change and now it's running faster, it's running more efficiently, or you refactor this thing in a really clever way. And just putting that in there, I think, can go a long way. I highly recommend that. However, speaking of praise, don't just say good job, good code. Be specific and be sincere about it. Point to things that they actually are doing well. Just like in real life, you shouldn't. If you really want to make somebody feel good, don't just say you're a good person. Say, I really appreciate that thing you did yesterday. It made me feel better. It made my friend feel better. Right? I noticed that specific thing. Be sincere about it. It actually means something. Consider the scope of the review. People do this. People violate this a lot. It tends to slow down code reviews. Is that somebody has fixed a bug or added a feature, and they've shown you the code they've changed. Stick to that code as part of your code review. Don't go hunting around for other problems outside of the code that they changed. Doing so just lengthens the code review process, which I've already established is not a good thing. And if you do happen to spot something, then you can always create another issue in your tracking system and raise that. But as a general rule, keep your comments and your review to the code that changed. Now, there are a couple of exceptions to this. One is if you spot something, it's a really simple change. It'll take them 5 seconds to change it. Maybe there's a spelling error somewhere. You can point that out. That's okay. Or the other thing is sometimes there may be code that they didn't touch that's affected by the code that they changed. In that case, yes, let them know that. Maybe if they've refactored some code and now the name of the method or the name of the class doesn't make sense, doesn't match, even though they didn't change that. Maybe they should change it. So there are times when it does, but still think about the scope of it and consider that, and don't go trying to go way outside of that scope. I got some build slides on here. All right, good. Confirm your assumptions. There may be problems in the code that really aren't problems. For example, if maybe the code is slow and you notice that it's very slow, but maybe that isn't a requirement. Maybe speed is not a requirement. Maybe it's a batch process that runs in the middle of the night and it's going to finish well. So what if it takes 10 minutes to run? It's still done well before everybody comes in the morning. But that might be an issue if somebody clicks a button and they're waiting for the screen to come back. 10 seconds could be a long time. 10 minutes is unacceptable. But just understand whether or not, just because it seems a problem to you, is it a problem in the context of the project that you're building? And then finally, stalemates. I mentioned that I told you I'd come back to this. Stalemates are when the reviewer and the author just dig in, and they're playing ping pong with this. The reviewer is sending back a list of issues. The author is saying, no, these are not issues, and there's nothing happening in that. And that does sometimes happen. And when it does, there are some ways to address that. I'm going to list these in order of what you should try, because first of all, there's back and forth. Nothing's getting done, and then tension. Now you're thinking yourselves as adversaries instead of being on the same team. So here's the things you can do in order of what you should try them. One is just have a conversation. So generally speaking, most code review processes do not take place in person. They're done through a system where you send things electronically. You might not even be in the same city or the same country. So you send information electronically back and forth. Here's my code. Okay, here's my comments on it. Okay, here's my response to those comments. And written communication is imperfect. It lacks the nuances of spoken words, lacks the nuances of physical gestures, so on. So just have a conversation. Walk over to the person's desk, get on a Teams call, whatever, and say, hey, let's meet for 10 minutes and figure out. Maybe it's just a communication issue. Let's figure out where we all each are and resolve this. Often that will solve it right there. If it doesn't, it's possible that you didn't do your homework up front, that the project has some ambiguity in its requirements, and you need to step back. You need to get into a room with a whiteboard, or a virtual room with a virtual whiteboard, and actually start talking about how the system should be designed. And this is kind of backing up to the beginning of the design of the system. And often that will resolve it. Consider conceding. Ask yourself, is this a hill I want to die on? Is it worth holding up the code request, or the pull request? It's possible that I'm right and he's right, or she's right. It's possible that we're both right, and even if I'm convinced that I'm more right than they are, is that worth holding things up for? I may decide I must concede. And finally, the last resort, escalate. Bring it up to the project manager, the project owner, the manager, the boss, and have them make a decision. But I would say that would be the last resort. I would do these in the order in which they are presented right here. Always consider that your goal with a code review process is to improve the code. It doesn't mean the code has to be perfect. The way I've heard this phrase is that we want to improve the code by a letter grade. So if you get code that's like a C minus and you get it up to a B, that's pretty darn good. You've improved the code. It's better than when it started. If only trivial fixes remain, then it's okay to pass that review process. Just something to consider, rather than if there's 1,000 different things that need to get fixed and they fix all the major ones, that's probably okay. Just think about the goal of this is to improve the code, not necessarily to make it perfect. Over time, it'll get better and better. So if this time you get it up to a B, the next time you get to an A minus, the next time you get to an A, if each iteration you're getting it up a letter grade or a half letter grade, the code will improve over time. This is just a tip that a lot of times you'll get code that has the same problem multiple times throughout the change set. You don't have to repeat the comment over and over again. You can just say, see my comment above. Just a tip for saving writing and reading, make it go a little bit faster. And slow down. This is code reviews require a lot of mental energy. Don't rush through it. Block off some time and block off a finite amount of time. I'd recommend not reviewing more than 500 lines of code per hour. I recommend limiting your reviews to 60 minutes at a time. If it's taking you a lot longer than that, maybe that's a sign that the code reviews are too long. And we're going to address that later on. Communicate clearly. I talked about being non-threatening in communications, but also be unambiguous. Let them know. Don't let them guess what the problem is. Be very specific about what issues you found in there. Write a description of any issue you found. Written communication is hard enough without being vague or ambiguous. All right, so I put this slide in here. This whole section here, I talked about a lot of things. I think these are the biggest ones. Working high level to low level. Consider the goals and the scope of your review, and don't make it personal. Communicate effectively, but respectfully. Don't attack the person. Describe issues in the code. That's a summary of the last, dozen slides or so. Are there any questions so far? Oh, wait 5 seconds. Decide. There are no questions. All right. All right. So the next is the code author. That's the other party involved in this. The code author, the person that's actually writing the code. What can they do to make the review more productive? Well, the first thing is review your own code first. Your mother doesn't live in your code. You'll have to clean up after yourself, right? So before submitting a pull request, just take a few minutes, step back and look at your code. And often you'll find things that are just simple and easy to correct, things maybe you missed while you were writing it. Just that extra read through of your code will do wonders for catching just silly mistakes, which everyone makes. There's no harm in that, but it's embarrassing if somebody else sees something. Maybe removing commented out code, for example, or running your code. Make sure you run your code one time. Make sure it works. Make sure you. Well, here we go. Let's see. Test your code. Test it before. Compile it. Test it manually. Run all of your automated tests, all your unit tests, your integration tests, your end-to-end tests. Run them all before you submit the code review. In fact, run them for the entire project, because sometimes, what do they call that? The butterfly effect. Sometimes you change code over here and it affects the system over here. So make sure that you're running all of these automated tests before you do that, and correct any issues you found before submitting the pull request. And just like I recommended the code reviewer use their computer, the code author should do the same thing. Use the computer for the things that it's good at. The compiler, a linter, a test runner, all those things, they're your friend here. That doesn't free you from the responsibility of also running it manually and clicking the buttons or whatever it is, looking at the database, make sure data is updated, but use the computer for things that it's best at. It'll save you a lot of time. Write a good summary. A clear change list description is really important. Let the reviewer know what it is that you've changed, so they know what to review, and write it clearly and ambiguously. And also, this applies also when you're responding to feedback. So if they send this pull request back to you after the review and say there's issues with it, then respond clearly. It's better to add too much context than too little context. Maybe list the frameworks that you're using, or why we're using this API, because the reviewer might not be familiar with the project. I've said it many times already. Communication is difficult, and miscommunication can be dangerous. Here's a big one that a lot of people forget about. Keep your change sets small, because smaller the change set is, the more likely it'll come back to you. It'll get it done faster. So it's better to scope it to one bug fix, one new feature, maybe just a small subset of a feature. Fast feedback is important. It'll prove this whole shift left principle on keeping the costs down. Try to keep your code change sets to no more than 400 lines of code. That's a number that I've read. It's kind of arbitrary, but just think about it. It's a good number. And if you're submitting larger change sets, then look for ways to split them up. Think about ways, maybe if I'm changing 20 different files, do I really need to change 20 different files? Maybe I'm working on 2 or 3 features at the same time. Maybe I ought to split that up into multiple change sets. It'll make things easier for the reviewer. It'll make feedback a lot faster for you. So narrow the focus of your changes. One way to keep change sets small is to limit to only one feature or one bug fix per change set. Another way is separating functional and non-functional changes. And what I mean by that is the canonical example. So non-functional changes would be things like refactoring code or changing the formatting, for example, changing the indentation of it. And the big challenge with this is that if you're using comparison tools like GitHub and Azure DevOps, and every source control system has these code comparison tools. If you're making refactoring changes or you're changing the indentation, that's going to affect every single line of code. And it's going to show every single line of code has changed. Well, if that's happening, then it'll be impossible to see what the functional changes are. So if you're doing something non-functional, like some refactoring, make that its own change set, make that its own pull request, and have that approved first, and then make the functional change, where you're actually going to change specific lines of code to make it clear what lines of codes have changed. And stay cool. Respond graciously. You're going to get back. Don't take this personally. The code is not you. Yes, you should be proud of it, but it's finding an issue. The code is not a reflection on you. Sometimes it's difficult to do that, but especially if the author hasn't listened to this presentation and they're pointing fingers and they're using language that makes it sound like you are a bad person because you wrote this. You broke the code. if they're using really aggressive language, it's hard not to take it personally, but realize that you guys are on the same page, that really they're just trying to make the code better. Maybe they're not a great communicator, but understand that and be patient with them. Be patient with them even when they're wrong. Reviewers make mistakes. They say, hey, this is a problem. And you realize, oh, wait, that's not a problem. They just misunderstood the requirements. It's supposed to work this way. And just slow down and explain it to them. And maybe when that happens, that might be an opportunity to improve the readability of the code. So maybe there's something in the code which gave the impression that it was doing one thing when in fact it was doing another. So maybe that's good feedback as well. That you can make the code a little bit more readable so they can understand the intent of it a little bit better. So even if they're wrong, maybe there's still some good information that you can pull out of that. And so answering questions with the code is a really good way. Refactoring to make the code more readable, that's a good reason to refactor, eliminate confusion. You may want to go back and just make the code more self-documenting, providing the two best ways to do that. One is to provide really meaningful names to methods and to variables, and the other is to keep your methods to doing a single thing, so they're not, don't have a method that does like 10 different things. Respond quickly. This, just like it's really helpful for the reviewer to start quickly so they can get feedback quickly, it's also really helpful for you to respond quickly. Increase the speed of that feedback loop. Everything will go a lot faster. Things will still be fresh in their mind. If there's more feedback, they'll be able to get back to you quicker. The faster we can make this loop, the better we're going to be about it. And again, there's a balance. The code author, they've got other jobs. They may be writing something else at the same time. So maybe they can't just drop everything as soon as the pull request responses come back. But be cognizant of that. The longer you let that sit and wait around, then the further away you can get from the original code. Things won't be fresh in your mind. Code boosts will start to change, so it'll be a little harder to merge things afterwards. Do that. And this is a suggestion that maybe ties should go to the reviewer. Again, this is a hill I want to die on. And if we're both right, generally speaking, what I say is, you know what, if it's a change that I can make, often making the change is faster than arguing not to make the change. So that's a rule that I typically go by. If we're both right, even if I know that I'm more right than they are, and it's not going to take a lot to concede and just do what they want me to do, then I'll just do it. You don't have to agree with that. That's just my opinion. All right, so this is summarizing the slides that I just went through, the code author improvements here. One, review your code first before you submit it in. Keep your change sets small, keep them focused. Create readable code, self-documented code. Communicate clearly in both your change list and in your responses to issues. And don't take it personally. You guys are all on the same page. You have the same goal. You're trying to make the code base better. That's your goal. And even if it sounds that like they're being adversarial, they're still their goal is still to make the code base better, which is exactly what your goal is. And these are the things that actually, you probably noticed that there are some things that fell under both categories, both the reviewer and the author. One is to shorten that feedback loop. So start as soon as you can. Don't spend too much time on these review processes. Finish as soon as you can. Communicate very clearly and ambiguously, but respectfully, and don't make this personal. I think this is a big piece of it. So that's the code author, there's the code reviewer. There's actually one more person involved, and that's the boss, the manager. And the manager can do things to make this code review process better. One thing they could do is to make sure that everybody, all of your developers, are also reviewing code. Spread that knowledge across the whole team, make them sure they understand the review process, make sure they understand different parts of the system. This is good for them. It's good for their career. It's good for the system as a whole, because people go on vacation, people win the lottery, people get hit by buses, at least hypothetically they do. And it's a really good idea for everyone to have that experience and get better for all the benefits of code review. Everyone can benefit from that. Rotate code reviewers. I've fallen into this trap myself where, I'm always reviewing Williams code because I understand Williams part of the system and I can review it a lot better. I don't really understand Harry's part of the system, and so I don't really want to review his code because I don't know it at all. But it's to my benefit to make sure that I'm reviewing different parts of the system. So don't always have it. And plus, William and I have a really good relationship. I'm more likely to be favorable and approve his ones, but just because I like William, he's a good guy. Whereas Harry's, yeah, he's kind of a jerk. I might be more harsh on him. Let's see. In your source control system, or in your DevOps system, whether it's GitHub or Azure DevOps or some other system, almost every system has the ability to force code reviews. So you cannot say no commits directly into the main branch. It has to be gone through a pull request, and somebody has to review that pull request. Sometimes you can say that a minimum of 2 or 3 people have to review that pull request and approve it before it is actually merged. Set those policies up in advance, and so let the system enforce them. And this is a really important one. Foster a culture of teamwork. There's a myth that somehow the reviewers and the authors should be adversarial, that they're at odds with each other. They are not. I've said this many times already tonight. Your goals are the same. You're on the same team. Your goal is to make the code better. You're not attacking each other. You are just trying to find ways to improve the code base, whether you're the reviewer, whether you're author, and it's up to the manager to make sure that is the message, that these things like, grading you down if somebody catches a bug, that's foolish. That's self-defeating. Now you're going to discourage people from admitting to bugs. They should be admitting to bugs because they want also to improve the quality of the code. Here's a good code. A good team with a good code review process, improving their code base and improving each other. It's from this article here. And just a word of warning, a code review does not guarantee quality. Bad code could still slip through a code review. There's just multiple humans looking at it. It can improve the chances of quality code, but it's not a silver bullet. There's still other things, and doesn't free you from responsibility of automated testing and user acceptance testing and all sorts of things like that. And just reiterating, you're all in the same team. You have the same goals. There's a bunch of links here, articles that this information came out of. I'd encourage you to read some of those. I know it's a lot here, but I think I took the highlights of these articles and I put them into this slide deck. And this is a link to this slide deck. So if you want those links, all you need is this link right here, and then you'll have the slide before. So you need to go to that tiny URL, or you can just take a picture of that barcode, take you right there. Leave that up for about 5 more seconds, and then I will say sincerely, thank you so much. I will pause for questions right here. Let's see, this is, while I'm doing that, these are all my slides here. And this is me. All right. A couple of there's the TV shows I talked about. And there's Sam. Hey, Sam.
Hey, David. Thank you. Great presentation, as always.
My pleasure.
Before we adjourn, anyone have any questions or comments for David? And it looks like it was crystal clear. It was very well delivered. So I can understand why there are no questions. Just out of curiosity, though, any stories from the trenches regarding code reviews that kind of stick out in your mind from past experience?
Oh, man. I wrote this when I was an engineer, when I was actually writing a lot of code. And the last 3 years I've been an architect, so I write less code. Now I just draw arrows and boxes and cylinders. But let me think. So I have I've had that stalemate process happen a couple of times. And I think when I was working, I was a consultant working for Avanade years ago, and I remember we were all in this one bullpen, and like we were in one big room with just not even cubicles, just rows of tables and computers. And so when somebody would do a review process, then we always had the opportunity to walk over and actually sit next to them, and they would tell us, they would verbally give us the feedback. That was actually really nice, because then you could actually point to the code and clearly say what this is, and if they misunderstood something, and then you could have that conversation right away. We've gotten away from that, especially in the last few years during the pandemic. It's become a lot harder. I do a code review process, and I didn't even understand what the code was supposed to do. I'd look at the requirements, I'd look at the code. Sometimes I had to start with a phone call. Tell me what this code is supposed to do. I'm not clear how it addresses that.
Gotcha. Okay. Well, no questions in the chat. However, 2 compliments, and I echo those
Daniel and
sentiments.
Dimitri.
They're all stating a great presentation, and I couldn't agree more.
Thank you.
Before we adjourn for the evening, just wanted to share a couple more slides in closing.
Take it over.
And yes, if I would please.
Or I'll stop sharing.
All right. So the question on everyone's mind is the meeting, will it be recorded and will it be available later? Yes. And if you subscribe to my channel, youtube.com/@SamNasserMVP, you'll be able to get the upload notifications. In addition, tech events that I post on my blog, samnasser.blogspot.com. And again, if you would please subscribe to that to get the updates. Last but not least, the feedback eval. And let me take a moment just to paste a couple links into the chat window. And give me 1 second, and that will be posted in chat in just a second. Okay, so you have 3 links posted in the chat window for the YouTube site where the recording will be posted, my blog where the tech events are posted, and last but not least is the feedback eval form, so we can provide David with some constructive criticism.
I'll post links to my YouTube channels here, if you don't mind.
Excellent. For those that are in the job market, I always mention devitjobs.com. It's a great website that allows you to filter on the location, whether you're working remotely or in person, and as well as the type of technology that you'd like to be working in. So it's a free website. Check it out at devitjobs.com. Lastly, if you need to get in touch with me for any reason, my email, snasser@nistechnologies.com. You can also find all my social links, YouTube, blog, etc., all on linktree/SamNasser. For attending, forward to seeing you all next month. Good night, everyone.
Good night. Thanks again.
Thank you, David.
This conference is no longer being recorded.
Have a great evening.
Thanks, Sam.
All right. Bye, everyone.